Good evening. Today we'll discuss part E. Six marks questions. Of integration. So we are going to discuss 6 marks question. 2014 March. March 2014. Prove that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. And hence evaluate integral 0 to pi by 4 log of 1 plus tan x. See, while revising the integration, I told you there are some formulas in definite integral. Instead of proving all of them, we shall prove whatever is required based on the question paper. This is one of the formula. So first we are going to prove this, and using this we have to evaluate this integral. So let us first prove it. Proof. Put a minus x equals t. Then what happens? Dx is going to be minus d. Actually, minus d, substituted minus sign there. So this is the problem of definite integral. We are going to change the limits also. When x is equal to 0, t is equal to a. When x is equal to a, t is equal to b. So because we are using substitution method, taking a minus x as t, we are going to change the limit. I have changed the limit. When x is equal to 0, t is equal to a, and when x is equal to a, t is equal to 0. So consider right hand side limit, RHS. In place of 0, you have got a, and in place of a, you have got 0. F of a minus x is t, f of t, and dx is minus dt. So this you can write it as minus of 0 to a f t dt. This becomes plus only. Why plus? Because I will take out minus sign, and when I interchange the limits a to b, you get negative sign, therefore it becomes positive. So this formula you need to remember. 0 to a f of x dx is equal to minus a to 0 f of x dx. When you interchange upper and lower limits, value of the integral gets multiplied by minus sign. So there is one more formula, a standard one. F of x dx is equal to 0 to a f of t dt. That is, we say definite integral is independent of the variable. Definite integral is independent of the variable. So whether you have fx dx or ft dt, Therefore, what will happen to this ft dt is going to be 0 to a fx dx, that is equal to LHS. So we have proved that RHS is equal to LHS. Now the next thing is making use of this, we are going to prove this. Invariably 6 marks questions are always like this. They'll ask you to prove one result. Just as we had 5 marks question yesterday. There also one of the standard limit we are supposed to prove it. And then making use of that we are supposed to work the problem. But there the proof was more, the problem was comparatively easier and simpler. Here it is not so. Problem is little lengthy, proof is simple. So we have proved it. Now we have got to what's the problem given. See, what's the problem given? 0 to pi by 4. So all standard problems, standard methods. So you are aware of it, but by working again, and this helping you to recollect. You call the given problem as I. Let I is equal to, what's the problem given? 0 to pi by 4 log of 1 plus tan x. So we know 0 to a f of x dx f of a minus x. Whereas in place of a you have got pi by 4. Therefore we write this as integral 0 to pi by 4 log of 1 plus tan of pi by 4 minus x. Pi by 4 minus x. See, normal method we employ here is we consider I plus I. Most of the problem of using these formulas will be I plus I. That's a skill, and I have suggested that method, and that's a standard method, and we are using the same method. See, what we're doing is for the first I am writing the given problem. The second I am writing this problem with a small change. What is the change? This is log of 1 plus 1 minus tan x over 1 plus tan x dx. See, what's the formula we are using? Tan of a minus b is tan a minus tan b over 1 plus tan a tan b. See, in place of a, we have got pi by 4. In place of b, you got x. So here I am writing tan pi by 4. Here I am writing tan x. Again here I am writing tan pi by 4 and here x. But tan 45 is 1. Therefore this is a problem. So we have to remember this formula, or you can directly remember tan of pi by 4 minus x is 1 minus tan x and 1 plus tan x. That depends on your ability to remember formulas. So what is our next step? The next step is this is equal to 0 to pi by 4 log of 1 plus tan x plus 0 to pi by 4 log of, you take the LCM. LCM is 1 plus tan x. What do you get? 1 plus tan x plus 1 minus tan x. Algebra. We are taking LCM. So this tan x and tan x will cancel. So we write this as 0 to pi by 4 log of 1 plus tan x dx minus 0 to pi by 4 log 2 dx plus minus 0 to pi by 4 log of 1 plus tan x. You can write this directly, but for the convenience of those students who have a difficulty in following this, I will explain it. See here, tan x and tan x cancels, you get 2. Denominator is same. So this is equal to log 2 minus log of 1 plus tan x. What's the formula I'm using? Log a by b is log a minus log. Just observe, these two will cancel. So use this formula to get that. Those two will cancel. Left hand side you have got I plus I is 2i. Log 2 is a constant, take it outside. Integration of 1 is x. The limit is 0 to pi by 4. If you simply substitute, you will get pi by 4 log 2. That is not the answer. Our problem is I, but we have got 2i. Therefore, what is I should write? Pi by 8 log 2. See, this problem is usually asked in CET also. So, what is the method? Remember, pi by 8 log 2. Standard problem 0 to pi by 4 log of 1 plus tan x dx is pi by 8 log 2. So, you can take that answer. So, with this, we will move on to July 2014. July 2014. Again, 6 marks question only. Prove that integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. And hence evaluate integral 0 to pi by 6 to pi by 3 dx over 1 plus root tan x is the problem given. So first we have to prove this, then using that result we have to evaluate this. So let us prove. The previous problem we had put a minus x as t. Same procedure. Instead of a minus x, you have got a plus b minus x. So put a plus b minus x is equal to t. What is dx? Dx is minus dt. Substitution problem of definite integral. We need to change the limit. When x is equal to a, so minus a plus a will cancel. T is equal to b. When x is equal to b, very clear, t is equal to a. So what will happen to the right hand side? A has become b. A has become b and b has become a. A plus b minus x is t. So f of t. Dx is minus dt. This we can write it as a to b ft dt. How? If you interchange upper and lower limits, you get a minus sign, there is a minus sign. This you can write it as integral a to b fx dx, that is equal to LHS. What is the method we have employed? Definite integral is independent of the variable. So let's go to the given problem. The problem given is, we call the given problem as I by 6 to pi by 3 dx over 1 plus root of tan x. We can write this as pi by 6 to pi by 3 dx over 1 plus root of tan of a plus b. A is pi by 3, b is pi by 6 minus x. See, pi by 3 plus pi by 6 is pi by 2. So you have got tan of pi by 2 minus x, which is cot x. You need to have the knowledge of allied angles. So what we have got now? 0 to not 0, pi by 6 to pi by 3 dx over 1 plus root of tan x, that is equal to pi by 6 to pi by 3 dx over 1 plus root of cot x. Now I will write this cot x as pi by 6 to pi by 3 dx over 1 plus 1 over root tan x. Because cot x and tan x are reciprocal function. If you simplify this, you will get pi by 6 to pi by 3 root tan x over 1 plus root tan x by taking LCM. I told you in the previous problem, the method is you always take I plus I. First I am writing this. Pi by 6 to pi by 3 dx over 1 plus root tan x. For the second I am writing that pi by 6 to pi by 3 root tan x over 1 plus root tan x. You can write this as pi by 6 to pi by 3 1 over 1 plus root tan x plus root tan x over 1 plus root tan x dx. See, because both the integrals are same, we can combine that. So you have got 2y is equal to, take the LCM, pi by 6 to pi by 3. You get 1 plus root tan x by 1 plus root tan x. That will cancel. You get pi by 6 to pi by 3 dx. Integration of dx is x. What's the limit? Pi by 6 to pi by 3. That is pi by 3 minus pi by 6. That is pi by 6. So what do you have? You have 2y is equal to pi by 6. But what we want is I. Therefore I is equal to. So we are employing the same procedure using the formula I plus I. You get dx. That is pi by 6. But I plus I is 2i. 2i is pi by 6. Therefore I is equal to pi by. So with this we shall move on to March 2015. See, March 2015 paper. I am not working because it is same as this problem. July 2014. The same problem they have repeated, so we can skip that. We'll move on to March 2016. March 2016 will work. We repeat the problem, so whichever is repeated, I'm just skipping that so that we get time for the other part what we have not covered. We will move on to March 2016. Integral, prove that. Integral 0 to 2a f of x dx is equal to twice of integral 0 to a, 0 to a, f of x dx if f of 2a minus x is equal to f of x. This is equal to 0 if f of 2a minus x is equal to f of x. And hence evaluate 0 to 2 pi cos to the power of 5x dx. Now we have got to first prove the result. So what we do is first we shall prove the result and use the result for working the problem. Proof 0 to 2a f of x dx can be written as 0 to a f of x dx plus a to 0 f of a to 2a f of x dx. See here, there is a formula which has been proved. Now we have to recall the formula. A to b fx dx with a to b a to c fx dx plus c to b fx dx, where a is less than c less than b. You can cut the limits. So we have cut at c, then proceed to b. Same method we have employed. So here you should remember the proof you have need to remember. We have to put x is equal to 2a minus t. How to remember? The problem has got 2a minus x. In 1, in this integral you put. So what will happen to dx? Dx is going to be minus t. What will happen to the limit? We are substituting this only in the first integral. When x is equal to one thing, not in 1, you do it in 2. When x is equal to a, t is equal to 2a minus a, that is also a. When x is equal to 2a, how to remember how to put it into is, because finally you should get 0 to a. So this 0 to a don't disturb. This a to 2a, that only you should change. Therefore, in this integral you are putting 2a x is 2a minus t. When x is equal to 2a, t is equal to 0. So what will happen? The first integral you write as it is. 0 to f of x dx is as it is. The second integral, the minus sign, write minus sign. In place of a, you have got a only. In place of 2a, you have got 0. And write this as f of 2a minus t dt. Now, 0 to a, f of x dx you keep as it is. See, in place of x, we have got 2a minus t. In place of dx minus, we have got minus dt. And the limit has changed, a has become, a remains as a, 2a is 0, therefore a to 0. Now, if you interchange this 0 to a, you get a plus sign. So it is plus 0 to a, f of 2a minus x dx. I've used two formulas here. One formula is by interchanging the limits, the minus sign goes. The second formula is definite integral is independent of the variable. Now we are going to prove this. For that, I use this space. I use this space. Now, case 1 you say. If f of 2a minus x is equal to f of x. So what will happen? This is going to be 0 to f of x dx only. 1 plus 1 is 2. Then RHS is equal to twice of 0 to a f of x dx. Repeat, the condition given is if f of 2a minus f of x. So if I replace f of 2a minus x by f of x, both limits are set, therefore I can add that. The condition 2. What is condition 2? Case 2 we can say. If f of 2a minus x is equal to minus of f of x, so this is going to be negative. So these two will cancel. RHS is equal to. So we have proved the result, but making use of this result, we need to evaluate this problem. Which problem? Cos to the power of 5. So look at this problem and the result. What is here? You can very well see 2a is nothing but 2 pi. So what is f of x? F of x is cos to the power of 5x. So if f of 2a, what is f of 2a minus x? Find out what f of 2a minus x. In place of 2a, you should write 2 pi. So what will happen? It is cos to the power of 5 into 2 pi minus x. So what is cos to the power of 5 into pi minus x? Cos of 2 pi is 360. 2 pi minus x, isn't it? So this is equal to same cos to the power of 5x. The reason being, you recall A, S, T, C. The cosine is positive here. 2 pi means 360. So 360 minus x is in 4th quadrant. So cos of minus x, 360 minus x plus cos x. Therefore, it is positive. So what you can do is, now you can write this problem as twice of 0 to pi cos to the power of pi minus x. Why? Because it is f of x. F of x is a is pi. You understand this? So what will happen is, this is twice of that. Now what will happen to this? This is 2 minus 2 0 to pi cos of x dx. So cos of x dx or cos to the power of 5x dx. The given problem, we have called it as, they have asked us to evaluate 0 to 2 pi. So what will happen is, this is going to be minus 2y. Therefore, the answer is going to be 0. You can bring this minus 2 at this side. So 3i is 0, therefore answer is 0. So we have made use of 2a equal to 2 pi minus x. But here it is positive. But when that is positive, it becomes twice of 0 to f of x dx. So it becomes pi minus x. Pi minus x is 180 minus in the second quadrant. As I said earlier, ASTC. So this 180 minus theta, where cos is negative. Therefore, it is a negative sign. Therefore, answer is 0. Let's move on to the next problem. The next problem is July 2016. Prove that 0 to a f of x dx is equal to 0 to a f of a minus dx. First, we have to prove this and then evaluate. This I am not going to prove it because it's already proved in March 2014. The proof I am skipping, but the problem given I am going to work. Evaluate. It looks like a very big problem, but not so. Evaluate 0 to pi by 2. 0 to pi by 2. Two log sin x. Problems look too big, but it is not so. 2 log sin x minus 0 to pi by 2 minus they are given 2 log sin x minus log sin 2x dx. You have to make use of the result. So what we do is, we will write this as 0 to pi by 2. I will take out 2. I will write this as log sin x dx. Minus, I separate the limit 0 to pi by 2 log of 2 sin x cos x. The problem looks lengthy, but it is not difficult. You should remember, use sin 2x is 2 sin x cos x. Then we are using one formula. What's the formula? Log m and p is log m plus log n plus log p. That formula we are using here. So you will get 3 integrals here because 2 is one integral. For log 2 is 1, log sin x is another one, and log cos x. So you can write this as 2 into 0 to pi by 2 log sin x, you write as it is, minus So let us put a bracket. Integral 0 to pi by 2 log 2 dx minus or rather plus 0 to pi by 2 log sin x dx plus 0 to pi by 2 log cos x dx. I repeat what we have done. Log of m in p is log m plus log n plus log p. Now I remove this bracket. This becomes negative. This also becomes negative. So first I let log m plus p because there is minus and all the three are negative. Here 2 log sin x is 1. This is minus 1 log sin x. So this becomes 0 to pi by 2 log sin x. Minus log 2 is a constant kept outside. Integration of dx is x 0 to pi by 2. This minus log sin x and 2 we have got 1 log sin x. This I can write it as 0 to pi by 2 log sin x dx. What's the reason? You can write log cos x as log of pi by 2 minus x. F of a minus x is f of x. So pi by 2 minus x is sin x. Therefore you get log sin x. These two log sin x and log sin x will cancel. So what do you get now? You get 2y is equal to pi by 2 log 2. So what is I is equal to? No, there is no 2y actually. Y only, there is no 2y. So 2y is equal to minus pi by 2 log 2. That's your answer. We have not taken I plus I here. We have just separated limits. I repeat once again what we have done. I have written log sin 2x as 2 sin x cos x quadratic formula for sin 2x. We have not taken I plus I. Earlier from this trick there is no I. It's I only you can call it as. Because the problem is I only. We have not done I plus I. Here I have taken out 2 and written this limit. Then I have used log m, log n plus log p. Because there is a minus sign, you get all the three negative. So if this is 2 log sin x and minus log sin x, we get 1 log sin x. Log 2 is a constant, integration of dx is x. Now log cos x is nothing but log sin x. Because f of x is f of a minus x. So these two will cancel. Now you can substitute, you get pi by 2 minus pi by 2 log. So with this we will go on to the next question of March 2017. March 2017 paper we are going to work now. March 2017. The problem is integral minus a to plus a f of x dx is equal to twice of 0 to a f of x dx. If f of x is even, 0 if f of x is odd. This is standard problem in CET. You can remember, whenever if you find a problem in CET with minus a to plus a, without working you can take the answer as 0. Because I can't give twice of, because you can't work this problem there. So it will be a memory problem. But here first we have got to prove it. After that, we are asked to find out, evaluate minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. X cube plus x cos x. So first we have to prove it. Proof. You can write minus a to plus a, f of x dx is equal to minus a to 0, f of x dx plus 0 to a, f of x dx. What is the method you are employing? You are employing the method which I have already discussed. A to b is written as a to c plus c to b, splitting the limit. So now we will keep this as it is because you know that we are going to get twice. So this we are going to simplify. So then what we should do is put x is equal to minus 2. These things you need to remember. Dx is going to be minus a. And it's a problem of substitution, you have to change the limit. When x is equal to minus a, t is equal to plus e. And when x is equal to 0, t is also 0. So what will happen? I am writing only RHS. RHS is going to be minus a has become plus a. And 0 is 0 only. X is minus t because we have taken x as minus t. And this is minus dt. Plus 0 to a, that you write as it is. We have not altered the second limit. Now here, a to 0 will become 0 to a. 0 to a by taking out this minus sign. And I will write this as f of minus x dx. I am using one more formula. Definite integral is independent of the variable. Plus 0 to a f of x. Repeat, the proof is not difficult. Only thing you need to remember is you have to split the two integrals and remember to take or put x is equal to minus t. Rest is okay. Now what we have got to do is we have to take case 1. What is case 1? F of x is E1. That means f of x, f of minus x is equal to f of x. So these two is going to be same. F of minus x is same as f of x. Therefore, case 1, RHS is going to be twice of 0 to a f of x dx. Because f of minus x is f of x. Whereas what is case 2? F of minus x is minus of f of x. Because function is given to be odd. So this becomes minus of f of x, therefore these two will cancel. RHS will be equal to 0. So we get this result. The proof is over. Now we have got to evaluate the problem given. What's the problem given? And invariably, the answers will be 0 only, invariable. There will be an exception, but most of the time they give a problem where it is an odd function only. See what is f of x? Let us take f of x as x cube. Then what will be f of minus x? F of minus x is f of minus x cube. Rather, we can write this minus x whole cube. That is minus x cube. Therefore, x cube is odd. Let us take f of x is equal to x cos x. What is f of minus x? Minus x cos of minus x. Cos of minus x is plus, but there is a minus sign here. Totally it will become minus x cos x. So here also x cos x is odd. Therefore, answer for this is D. This is all. This odd plus odd function is odd. Therefore, answer is D. We'll move on to July 2017. July. See, these problems carry 6 marks. They are not difficult. And hardly there are 8 problems, they are repeating one of them. You can always be sure of getting this marks. Then we are going to July 2017. It's a repeated problem of previous year, so we will not discuss that. We will move on to March 2018. March 2018. March 2018. So the first thing is they have given prove that interval 0 to a f of x dx is equal to interval 0 to a f of a minus x dx. They have got this in July 2014. Therefore, I can skip that. But I'll take the problem given. What's the problem given? 0 to a. 0 to a. Root x minus root x plus root of a minus x dx. So you call the given problem as I. So f of x can be written as f of a minus x. So what we can do is 0 to a, x becomes a minus x. And here also x becomes a minus x. What will happen to a minus x? A will remain as it is, x becomes a minus x. So if you simplify this, minus a plus x, so this is going to be root of x. So normally I told you in this set of problem we take I plus I. So what we do is I plus I we take. The first I am going to write this. This is a very simple problem. So you can be sure of 6 marks. Plus, with the second I am writing this. When we combine these two and take the LCM, we get 0 to a root x plus root of a minus x over root x plus root of a minus x dx. That will cancel. You get x from 0 to a, that is a. So you have got 2i is equal to a. Therefore I is equal to a. Very simple problem. So with that we shall move on to July 2018. That also I can skip because the problem is minus a to plus a f of x dx. It is equal to twice of that or it is equal to 0. So we have proved that. But they have given a problem minus pi by 2 plus pi by 2 sin to the power of sin x. You know sin x is odd function because f of x is sin x if you take f of x equals sin x you take f of minus x is sin of minus x, that is minus sin x. So it's an odd function, therefore it is 0. I not worked the problem because similar problem we worked out. Only thing that you should realize is sin x is an odd function, and whenever it is minus a to plus a, if it is odd, answer is 0. If it is even, twice of that. Normally they don't give twice of that. Exceptionally, exceptions will be there, but in this examination so far they have not given. They have only given odd function. That's an understanding. So we will move on to March 2019. March 2019. The first part is has been asked number of years. 0 to a, just now we have worked out. F of x dx is no. 0 to a, f of a minus x. So I can write March 2014 they have asked. Then July 2016 they have asked. And March 2018 they have asked. And they have asked again in March 2019. So there is no need of proving this. Of course, the exam you got to prove. But here I am not proving it. But I take the problem given. What's the problem given? Evaluate 0 to pi by 2 cos to the power of 5x over sin to the power of 5x plus cos to the power of 5. It's a very simple problem. You call the problem as I. Use this formula 0 to pi by 2 cos to the power of 5 pi by 2 minus x because a minus x divided by sin to the power of 5 pi by 2 minus x plus cos to the power of 5 pi by 2 minus x. So what do you get? You take this I plus I. The first I am going to write the same thing. 0 to pi by 2 cos to the power of 5x plus sin to the power of 5x plus cos to the power of 5x dx. For the second I am writing this. Cos of 90 minus theta is sin theta. Sin of 90 minus theta is cos theta. So you can write this as sin to the power of 5x over cos to the power of 5x plus sin to the power of 7x dx. If you combine these two and take LCM, you get 0 to pi by 2 cos to the power of 5 sin to the power of 5x plus cos to the power of 5x. When you take LCM, you get the same thing here. So these two will cancel. You get x, that is integration of 1 is x, that is 0 to pi by 2, that is pi by 2. So 2y is pi by 2. How simple it is. Getting 6 marks is very easy. Only thing is you should have revised it. And July 2019 is same as July 2019 is same as July 2014 and other years. Same problem, everything is same, there is no change. So I am not going to work. We will move on to March 2019. But I'm sorry, March 2020, 19 is over. We will go to March 2020. March 2020. What is March 2020 problem? This is minus a to plus a. F of x dx. No, it is twice now the same problem they asked. But here they have given minus 1 to plus 1 sin to the power of 5 x into cos to the power of 4. Sin is an odd function. This is an even function, but when you multiply totally it is odd. So you can just write sin to the power of 5x into cos to the power of 5x is odd. Therefore, answer is 0. First, you have got to prove the result. Result you have got to prove it. Then make use of this formula. So with this, we will move on to September 2020. Wherever I can save time, which have been covered earlier, I am not working. This is September 2020. Same thing, 0 to a f of x dx is equal to 0 to a f of a minus x dx. Should prove this, we have asked. Proof we have done earlier. I'll take only the problem. 0 to a root x or root x plus root of a minus x. This problem also, just now we have worked in March 2019 paper. I worked the same problem. I have repeated the same problem, so I can skip this. And September 2021, because there was no exam in March 2021. So September 2021, they have given a problem which they are given July 2014 and July 2014 and July 2015. The same problem they have given, so I am skipping that. Next, April 2023. April 2023. The problem given is same as July 2016. Everything same. Proof, problem, everything same. I am skipping that. And August 2021. 20. This is April 2022. Now, August 2022. August 2022. The problem given is same as July 2016, same problem they have given. So no need of working. Then you can just check March 2023 and all, they have repeated the problems. I will not be writing them. The same, whatever problem was asked earlier years, they have repeated. So let us not waste time. We have got half an hour more. We will move on to the last chapter which I had planned to complete. That is differential equation. Equations. This is shortly called as DE. What's the differential equation? In each equation which has got x, y and derivative. That means function is there, derivative is there, or you can say independent variable is there, dependent variable is there, and derivatives are there. Such an equation is called a differential equation. For example, if you want to give 5 dy by dx plus 4 cos x plus y is equal to 7. Y equal to 0, you can say. Something like this. Or d square y by dx square plus 5x is equal to 4x, something like this. Any equation, I don't want to go into much details of this because you are familiar. Only thing is you should know that the differential equation has got independent variable, dependent variable, the derivative of the dependent variable in terms of independent variable. What do we say dy by dx? It is a derivative of dependent variable y with respect to independent variable x. And here it is second derivative, it can be any derivative, but derivative must be present. If you just write 4x plus 7y is equal to 0, it is not a differential equation because there is no derivative. But if I write dy by dx is equal to 7, it becomes a differential equation. The extent by your option, but derivative is present. To identify differential equation, an equation must have a derivative of any order. So here you get one more question asking what order and degree. And you always get one more question. There should not be any confusion. What is order? Order is the order of the highest derivative. Order of the highest derivative. That is not difficult. Supposing I have got dy d cube by dx cube plus d square by dx square plus 7x plus something. The highest derivative is 3. So we say order is 3. So very simple to identify. But you always get a question, find order and degree. Finding degree is very important. Degree is the power on the highest derivative. Supposing you are given d cube y by dx cube to the power of 4 plus dy by dx to the power of 7 plus 3y is equal to 0. The power 7 is here. That is not degree. Degree is the power on the highest derivative. D cube y by dx cube, the power is 4. So I repeat, order is the order of the highest derivative. Degree is the power on the highest derivative. But you should take care to see that it doesn't have a fractional powers. Sometimes they give square root of dy by dx plus something. So first thing you should do is remove the fractional powers if it is there, then only decide degree. That's why they use a word. Degree is the degree of the highest derivative is the polynomial equation. What's the meaning of polynomial equation? You know, a polynomial equation not have a fractional or radical powers. So when I take up the problems of the examination papers, I'll explain that in more detail, but I'm just giving an idea. Order is the order of highest derivative. Degree is the power on the highest derivative when the equation is polynomial. In other words, the equation is free from radicals. So, there was earlier portion was the differential equation had two parts. The first part was formation, and the second part was solution. We had two parts earlier, but in the revised syllabus, they have removed 9 points, that is formation, they have removed only solutions. So there are different types of solutions. So solution of differential equation by variable separable method. What is variable separable? Whatever form the equation is given, you have to express that equation in such a way that coefficient of x, coefficient of dx is a function of x only. And coefficient of dy is a function of y only. When we work the examination paper problems, we'll be able to discuss that in detail. But just for understanding, I'll just work two problems. So here, as I said earlier, the formation is not there in the syllabus. For the formation, we need differentiation. For solution, we need integration. So if you are a good student of integration, then only you can work problems on differentiation. Because all the types may come. So I'm just discussing today what is the variable separable. Whenever an equation is given, you have to segregate that in two parties, right? Dx part and dy part. So dx part should contain only x terms. X terms, it can be any equation, sin x or whatever it is. all x, the coefficient of dx should be a function of x only. That's what we are written. And coefficient dy should be function of y only. That's the first part. Given a problem, you should first see whether you can segregate that into two parties. If you cannot separate them into two parts, then you cannot work this problem by that method. So we have another type, what is called homogeneous equation. I'm just listing them. We'll go to the details later. Homogeneous differential equation. Homogeneous differential equation. Next one is linear differential equation. So we are solving by variable separable method, not all the problems. The problems where you can segregate them into two different parties. Some of the problems which we cannot segregate, then we will check whether it is homogeneous. We'll discuss what is homogeneous later. So have an idea. It's a very simple chapter. You need a simple knowledge of integration. Whatever you are learned, integration by substitution, integration by parts. There is no definite integral here, only indefinite. Okay? We'll just work one or two problems on variable separable method, then move on to homogeneous. Let us take the problem. Solve dy by dx is equal to 1 minus cos x or 1 plus cos x. Now, can we separate them into two different parties? Yes, it is possible. This is x function, x, therefore it should be dx. So you can write this as dy is equal to 1 minus cos x over 1 plus cos x. Supposing it is not possible to separate, we are not working by this method. We are taking problems which can be worked by this method into dx. The first part in variable separable is to check whether it is possible to divide a given problem into two parts, dx part and dy part. It is possible here. The second thing is you should integrate that, that's all. Integration of y is very easy. dy is y. It is easy. How to integrate 1 minus cos x, 1 plus cos x? You have to recall. What is 1 minus cos x? 2 sin square x by 2. What is 1 plus cos x? 2 cos square x by 2. 2 and 2 cancels. What do you get? Tan square x by 2 dx. How to integrate tan square x by 2? Tan square x by 2 is not integrable. Whenever there is an integrable, not integrable functions, see whether it is possible to convert into integrable function format, then integrate it. Yeah, there is a formula. You can write tan square x by 2 as secant square x by 2 minus 1 dx. The secant square x by 2 is integrable. 1 is also integrable. What is the integration of secant square x dx? It is tan x. What is the integration of secant square ax dx? Is tan ax divided by a. So what is the we have got in place of a? You have got half. So what is this is going to be? Here y is there. This is tan x by 2 divided by half means multiplication by 2. 1 is x plus a very simple formula. Wherein we could segregate them into dx part and dy part. And we need a basic knowledge of how to integrate 1 minus cos x. I'll just take one more problem. Secant square x tan y dy, tan y dx or dy dx plus secant square y tan x dx is equal to 0. So here this tan y should not be here because we want dx to have only function of x as coefficient. Here secant square should not be there. So what we should do? We will divide by secant square x, secant square y. Is it possible to divide? So divide by secant square? No. Instead of dividing, what we can do is, the best method is to write this as secant square x tan y dy. This is some mistake I have done. This is dy. It's a mistake. Both are dx I have written. Dx is equal to minus secant square y tan x dy. So I don't want tan y here, I don't want secant square y here. So what I will do is, I will bring the secant square y here. Tan y, no, I don't want tan y here, but I want tan x here. So I will bring this tan x this side. I write this as secant square x by tan x. I can shift this tan x to this side. Now I will shift this tan y to that side. This is an easier method. So first, write like this. We don't want tan y here, shift it other, it goes to denominator. We don't want tan x here, it comes here. Next part is, you have to put the symbol. There is a minus sign that you should remember. A very simple problem of substitution. You can remember that the formula I have given you, f dash of x over f of x dx is log of f of x. So this is f dash tan x, if you take f of x, this is f dash of x. So this is log tan x. This is log, that is a minus sign, log tan y plus c. You can leave it like this, but sometimes, especially in the CET, you may have to simplify. In that case, we can write log tan x plus log tan y is equal to c. That is log tan x by log tan x is log into tan y. Here instead of c, you can write it as log c. Therefore, you can write tan x into tan y is equal to c or k or whatever it is. What's the formula I've used? Log a plus log b is log a. Now you can leave it here, no problem in the examination. But if they have asked you to prove, then you have got to use the formula. We'll work one more problem of variable separable. Then move on to the homogeneous part. We'll take this one more problem. dy by dx is equal to 1 plus x square into 1 plus y square. Variable separable, I just work one more problem. So we'll work more problems when we just work the question papers. dy by dx is equal to 1 plus x square into 1 plus y. The first thing that we should see, is it possible to segregate them into different parts? It is possible. So you can send dx aside and bring. So this is dy over 1 plus pi square. This is 1 plus x square into dx. So this is standard form. What is the standard? This is tan inverse y. What about this? 1 is x square is x cube by 3. It's a very simple problem if you can understand. One of the years they are given problem dy by dx equal to sine inverse. I'm just taking this example to let you know what difficulty is there if you are not good in integration. This is a problem given. So you can write dy, integration of dy is equal to sine inverse x dx. This is very easy. But you should recall you have to use integration by parts. So you need to use integration by parts. U is equal to sine inverse x and dp by dx. That we have done in integration. So I have just given some examples of variables available. Today we shall discuss the other one also, homogeneous differential equation. Homogeneous differential equation. A function of the form x to the power of n into y, f of y by x is called a homogeneous function. Definition of degree that we are going to discuss depending on the problem given. But what is homogeneous differential equation? It is of the form f of x by g of x, where f of x and g of x are homogeneous polynomial equations. Any equation of the form f of x by g of x, where f of x and g of x are homogeneous equation, the very important thing is they should be of the same degree. I'm not writing the definition, but I'm just reminding you f of x is a polynomial homogeneous equation, g of x also, but they should be the same degree. Such an equation is called homogeneous differential equation. How do we work homogeneous differential equation? We just work one or two problems. Take the first problem. Solve x dy by dx dx plus. Now you can write this as dy by dx is equal to x plus 1 divided by x. You can always realize this you cannot work by variable separable because this you cannot separate. Therefore, variable separable method is not suitable for this because it is not possible to express it as two different functions, dx part and dy part. It is not possible. Then we check whether it is homogeneous. So, numerator is one function, denominator another function. Degree of this is 1, degree of this is also 1. Therefore, it is a homogeneous equation. After recognizing that, There's a method for this that you should remember. Put y is equal to vx. This method is employed for homogeneous. The first part is should realize it is not possible to work by variable separable because we cannot have two different parties as x party and y party. You can't separate x plus y. Then we see whether it is possible to work by homogeneous. Yes, it is a homogeneous equation. For the homogeneous equation, the method is you have to put y is equal to vx. See, y is equal to vx. What is dy by dx? You are differentiating y with respect to x. Here also you should differentiate with respect to x. So this is a product. So keep v as it is, differentiate x, you get 1. Product rule. I keep v as it is, differentiate x, I get 1. Now I keep x as it is, differentiate v, I get dv by dx. Try to understand. After realizing that the problem is a problem of homogeneous differential equation, we should remember the substitution y is equal to vx. Now, you call this, you can just simplify this. What is x? X is x only. What is y? Y is vx. And what is denominator x? Now, you can take x common, you get 1 plus b by x, x and x cancels. Now you can call this as equation 1 and call this as equation 2. Repeat what I have done. Substitution is y is equal to vx. We are differentiating y dy by dx. We are differentiating with respect to x. That you should understand. Difference of y is dy by dx. Difference of vx is product rule. We keep v as it is, differentiate x, I get 1. Keep x as it is and differentiate y, rather v, we get dv by dx. Now what I do is, in place of y I am putting vx, I take x common. Now I have got dy by dx 1 plus v, dy by dx equal to x plus v plus x dv by dx. So from 1 and 2, these steps are same for every problem. In place of dy by dx, I can write 1 plus v because dy by dx is 1 plus v. Here I write as it is. Shilpa? Huh? Okay. Okay. So here dy by dx is x dv by dx. Normally you get one problem in the public examination, it's not difficult. Now you should simplify. This v and v will cancel. So what we have got? We have got 1 plus x into dv by dx. Now we are using the variable separable. How to, you should see that dx should contain x and dy by, so this 1 is there and x dy by dx is there. So I have got to segregate that. So how you are going to work out this, that you should see. So what do you have now? X dv by dx. How to solve this differential equation? Now, what is that we have done is a homogeneous equation in x and y has become a variable separable in v and x. So here, there we used to have dy party and dx party. Here we have got dv part and dx part. So what you can do is, you can write this as dv is equal to 1 by x into dx. Don't take dx in denominator. So you can write this like this. So integrate this. What is the integration of dv is v. What's the integration of 1 by x? Is log x. But what is v? V is y by x. So you can write plus c, log x plus c. So y is equal to x log x plus c. This is the solution. I repeat what we have done. First, we have realized it's a problem of homogeneous differential equation. We have used substitution y is equal to vx. Then we got a variable separable form. Then we use it. I'll just work one more problem and then stop. The other part, linear differential equation, is discussed in next class, that is tomorrow. Then we can work out the other problems. So let me work one more problem of homogeneous. X minus y into dy minus x plus y dx is equal to 0. So you can write this as x minus y into dy is equal to x plus y into dx. That you can write as dy by dx is equal to x plus y over x minus. You cannot work by variable separable because it is not possible to segregate dx part and dy part. Therefore, what we should do is check the degree of this. 2. Degree of this is also 2. Homogeneous. Therefore, immediately we should go for put y is equal to vx. Then what is dy by dx? V plus x dv by dx. I call this equation 2. Here what I do is, x is as it is, y is vx, 1 minus vx. Of course, x minus vx. You take x common, 1 plus v. You take x common, 1 minus 1. X and x will cancel. You call this the equation 1. Same procedure from 1 and 2. We have, so instead of dy by dx, I write 1 plus v over 1 minus v is equal to v plus x dv by dx. So dy by dx is equal to this expression, also equal to this expression. So we have got this. Now we need to simplify this. How to simplify that? So you can write 1 plus v by 1 minus v minus v is equal to x dv by dx. This algebra only. 1 plus v minus v plus v square is equal to x dv by dx. So v and v cancels. 1 plus v square is equal to x dv by dx. You have to be very careful in simplification. Now you can just decide very clear that solve by variable separable. What are the two parties? dv part and dx part. So you can write this as integral of dx by x is equal to integral of dv over 1 plus v square. This is log x. What about this? Tan inverse v plus v. Log x is x only. What is tan inverse v? Tan inverse, what is y is equal to vx. So What is V? V is equal to y by x. So tan inverse y by x. You can do that. So today we will just stop the class. Tomorrow I will discuss a brief linear differential equation. Just one or two problems. After that we will go to the question papers. What are the four normal questions in differential equation? Degree and order. Problems can be of variable separable, homogeneous or linear. So I have discussed today degree of differential equation, order of differential equation. I repeat once again. Degree is the degree of the highest derivative present in the equation. Order is the power on the highest derivative. Power on the highest derivative when the function is free from fractional or radical powers. Then we have discussed about solution by variable separable method, dx party and dy party. The second was homogeneous, where also by putting y is equal to vx, we are able to get a format which can be solved by variable separable. So tomorrow I'll just discuss linear differential equation, one or two problems, then go for the examination tips. Thank you. We shall close class today.